And for the final MLOps video, we are going to discuss how to deploy this on AWS. Again, building off on what we discussed previously for the Azure and GCP, we have a standard situation. We decided we want to do certain machine learning automation. We build a task. In this particular case, we had a medical cost prediction, right? So how did this look like is that there are multiple features that one can, as an end user, input: age, BMI, sex, smoking status, number of children, etc. And then you can predict the potential medical expenditures that you are going to expect. The data set can again be found in Kaggle. It's a specific task that's not very interesting for our current discussion now, but let's just assume for the sake of argument, we are done with the modeling part, which can basically be found in the notebooks model training. And then we have pickled it as a pickle file. And then what happens is, and what we are trying to achieve from this point on, as I said, this is the front end, what we expose our endpoint, and this is how it looks like. And this is how the sample web API call would also look like. So what are the post arguments that you need to input for this endpoint to basically get the predictions back. This is all great, and you tested this locally, and you know that this works. But now the question is, as you deploy it, how do you make sure that you deploy it, A, in a reproducible way, meaning using Docker, and B, how do you make sure that the MLOps principles are also integrated into this solution? Again, remember, this is just a walkthrough. For the more details, you can follow the code, the description, the documentation, and the links that I put into this repository. But let's get back to the architecture, and what I wanted to discuss in this short video is how does the incorporation of the MLOps principle actually look like. So the first couple of blocks are irrelevant for us until the containerization in Docker Hub. So basically, we trained the model. We already know what needs to be predicted, how the pickle file looks like, how the front end looks like, and now we want to, as I said, do the step A, and the step A is making it reproducible and containerizing the whole application, and then publishing the image in a Docker Hub. After that, we are going to take this image that we publish into Docker Hub, ingest it and consume it in our EC2 instance that we fired up from the AWS account, create a Docker container image again here, create a container, run the container, then create some load balancer and autoscaling group, which basically enables us to have and to handle increased traffic. And then we are going to deploy our application. In between, what we can do is make sure that as we are creating and publishing this container image on our EC2, that also certain steps are executed in between. Remember the MLOps steps, for example, taking from the DevOps principles, the CI and CD, where we make sure that automatically that all the necessary testings of our infrastructure, the data, the code, the model is executed. And this can also be implemented in between here. Now, going into more detail and how does this look like, you can find it basically in this detailed walkthrough PDF, but this will look something like this, and you will see it, that initially what happens is that you manage to test this locally. You already know that on your local host, the front-end application works. You can send the basically the arguments to your prediction endpoint, and the containerized container of your application also is functional. The code for the container, basically the Docker file, is also here available, and you see that we just basically take a very simple image. We copy all the files to the Docker container. We specify the working directory. We install all the necessary requirements, and then we expose our Flask application. Nothing more, very simple Docker file. As I said, we tested this locally. We know it works. Docker image works. Then we can share it on Docker Hub in order to consume it later on our EC2 instance that we fired up from AWS. Then we go to the AWS. We create our EC2 instance where we can do two things. First, we pull our image so that we can basically execute the same code on the same environment that we executed it locally, and we start our container. One step in between here that is not necessary and that we did in the previous example is integrating this with GitHub or some other repository. Remember, we containerized everything with our Docker image, so there is no need to spin it up or connect it to a certain code repository. And then when we are done with that, remember what we discussed previously in the architecture diagram. We containerized it. We're done with that. We deployed it to EC2. We created our container image, and now what we want to make sure is that our application can serve increased loads with load balancers and auto-scaling groups. Why they are important and how they actually do this and manage to handle increased traffic. You can find it in the official documentation. This is not the purpose of this video, but here in these screenshots, you can see how can you configure that for this specific EC2 instance that we fired up, the load balancers and the auto-scaling group. And then we are set, we are ready. Again, we are finished with this part of our diagram, which you can again find the detailed configurations in the files available in this repository, and then the application is deployed. And that would be the whole pipeline, the whole process that we wanted to implement. Obviously, this is not the full MLOps cycle. There are multiple components that can be implemented here, like monitoring, continuous training in an online setting, extensive CI/CD pipelines that can also be built into this, but basically just the small elements that are needed to automate this and to make this application more stable, more mature, and then at the end of the day, reduce the technical debt that allows for better developer efficiency.